Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed NERNST equation. You have derived a single electrode potential. Expression for single electrode potential you have derived. Now I will continue from that. Here now you want to calculate Ecell. Then how will you calculate? Now you are knowing electrode potential, single electrode potential. That expression you are knowing. Now you want Ecell. To calculate Ecell, capital E and down CELL you can write. Then Ecell is equal to that ER minus EL, electrode potential of right hand electrode minus electrode potential of left hand electrode. Then already you know that in Daniell cell, left hand electrode is Zn, right hand electrode is copper. Means Zn in ZnSO4, copper in copper sulfate. And both are joined by a wire, conducting wire, and wire through ammeter or voltmeter. Anything you can put. That you are knowing. Salt bridge is already there. That diagram you keep in your mind. Then here E cell is equal to ER minus EL. And you know what is the value of ER, single electrode potentially. Last class you have derived. I have discussed in details. Now we have to put the value of ER and EL. That's enough. And after that you have to just simplify it. Then here one important point I want to tell you while simplification. Here you have to understand. Here you will write electrode potential for the two electrodes. As for example, for copper, already you know copper you have derived, correct? 1 upon, and the end it came E is equal to E naught minus 0.509 divided by N log 1 upon Mn plus. 1 is because for metal it was concentration is considered as 1. Then this is expression for copper. For copper electrode, this is the electrode potential. E is equal to E naught minus 0.059 divided by N log base 10 and 1 upon copper ion concentration, 1 upon Cu++, means copper ion concentration. This is for copper electrode. Now same way you can write for zinc electrode, same way. Here also same reaction you have to do. All things are same. Zn also Zn plus 2 electron, that is a Zn metal. Okay, then you will get same type of expression. Only in the place of copper ion Cu2+, now you will get 1 upon Zn++. That's enough. Same things. E is equal to E naught minus 0.509 divided by N log base 10 1 upon Zn++. Correct? Common expression already you know. Common expression for electrode potential in general. E is equal to E naught minus 0.509 divided by N log 1 upon Mn plus. Here Mn plus value we are putting copper Cu for copper electrode Cu plus plus you are writing. For zinc electrode you Zn plus plus you are writing. That's enough. Now after that now you are knowing ER also you are knowing and EL also you are knowing. Means electrode potential of right and left both you are knowing. Then right side is copper, left side is Zn. Then these two expression you have to write. Correct? Only minus sign is there in the middle, ER minus EL. Here you will write both expression. For ER you will write the expression in big bracket you write. Full expression you write in a big bracket. Means E you will write, and for copper better you write ECU just to differentiate. ECU. And electrode, I told you how to represent the electrode. Then now Cu plus plus in reduction ion will convert to the metal, and Cu plus plus after taking electron it is converting to metal Cu. Hence E, near the E you write Cu plus plus oblique Cu. Correct? And that is for E, that is equal to E naught. Then again same things. You can write E naught Cu plus plus oblique Cu. Other things are same. For Zn also same thing you will write. E Zn plus plus Zn. E Zn plus plus oblique Zn, that is equal to E Zn plus plus Zn. But this is for subscript 0 you have to write, just like for standard electrode potential. Here you will write for Zn also, only because if you will not write copper Zn you will get confused. Hence you have to write for copper electrode Cu plus plus oblique copper for copper electrode, and for zinc electrode you should write E Zn plus plus oblique Zn, that is equal to E subscript 0 Zn plus plus oblique Zn. Correct? And end only again for copper you should write, for copper you can write that Cu plus plus 1 upon Cu plus plus, and here 1 upon Zn plus plus. That is only difference. Then now these two expression you will write in complete big bracket. For copper, first you have to write for copper in a big bracket you write. Minus again in a big bracket you write for Zn. Now while simplification you should be careful. You have written the correct, but now you have to calculate for Ecell. You have done minus, that is okay. Ecell, now we have written correct thing, ER minus Ecell is equal to ER minus EL. Then for the ER copper expression you have written, copper electrode expression, minus in another bracket you have written for Zn, complete expression, two expression. Now what you have to do, many things here I am briefing you, you can do by your own, but if you will follow simple in an ordinary way, simplification without taking any precaution, then it will be problem for you. It will create problem for you to get the result. You will get the result. A straight way also, in a general way, what you are doing, that way you calculate. Then you will get also you can get in the end, but you will in trouble. More step is required, complication will be there. Situation will become grim, means you may think what is happening like that. It will be not easy. But what I am telling you, that you do, then it will be easy. Only in 1-2 step you will get the result, Ecell. Then what is that things you have to take here? This things important step here you have to consider. Then see, right hand electrode expression you have written in one bracket, minus in other bracket, left hand electrode you have written, means for ZL. Then now you know that in bracket, ZN bracket means ER minus EL, EL I am talking about, that outside minus is there. Outside minus is there. And in bracket EZN plus ZN you have written, that E0 first term, second term is in minus. Second term is in minus. Hence, if you will remove, next step, if you will remove a bracket, then minus will become plus. Minus will become plus. Means before the ZN, log 1 upon ZN plus what you are writing, before that, that will become plus. Correct? And this E standard ZN plus that will be minus only because outside minus is there. Then minus E standard ZN plus ZN first term, and second term become plus 1 upon ZN plus. Okay, 1 upon. Then here you have to take after this step, next step you have to be careful. Correct? What you have to do? Then two type of change you are going to do. This now third step means you can say we have put that step is the first, ER minus EL, that is the first step. Ecell is equal to ER minus EL, first step. Second step you have put the expression. And third step now you have changed the sign you have changed. Correct? Third step. Fourth step, what you have to do? That both standard you bring together. Means E standard E copper Cu plus oblique Cu, that and ZN standard and copper standard both you bring together. Close. Means copper electrode minus ZN electrode, you write close. Then what you will get? You will get copper electrode minus zinc electrode you will get. Means you will get E standard Cu plus Cu minus E standard ZN plus oblique ZN. Now you have written close together. That you can write in one bracket. In one bracket you can write. Correct? Now after that what you have to do? What is remaining now? Log term is remaining. Two log terms are remaining. One for copper and one for ZN. Two log terms are remaining. Then here main things you have to do. That what you have to do, main things, that plus sign you write first. Means ZN is plus. ZN term is log base 10 1 upon ZN plus, that is before that plus sign is there. Then first you write that term, then you write negative term, means copper. Copper is negative, you know. Log base 10 1 upon copper Cu plus that is negative. Then now these two write in one bracket. These two term you write in the another bracket. Then now we have just simply rearranged both copper electrode minus copper standard copper E0 copper minus E0 Zn. You have written together. After that, you have written plus, because Zn log Zn you have written, means 0.059 will be there. That is carried on always. 0.059 divided by n. It is carried on. It will be with Zn also before log, and it will be with copper also before log. Then now major things you have done. Fourth step, that both standard electrode and standard galvanic you have written together. After that, in one bracket, after that plus sign you have written, and in other bracket you have written Zn. Just 0.5059 divided by n log base 10 1 upon Zn plus plus, means molar concentration of Zn plus plus, minus 0.059 divided by a small n log base 10 1 upon Cu plus plus. Correct? Molar concentration of copper ion. This is the fourth step. Now here chemistry is going to be finished, means chemistry step is finished. Now mathematics will come, math. Then here what you will do, that difference of two standard, you can write only E, you can write Ecell, you can write only Ecell, because it is of difference of two standard. Difference of two standard. E standard for Cu minus E standard for Zn. Then both are standard. If you put the suppose experimental value are putting, then that difference will tell the standard potential. That is called standard potential. Means for this two term, in the next step, means fifth step, E standard you will write. E standard CELL cell. Now difference both, you have both term you have to not write. Only E cell you can write. Standard E cell. Standard E cell. Correct? Then standard E cell you have written, means E cell. E cell is equal to E standard cell. That also, because this is the expression for E cell. Already one time you have written E cell. Now that is equal to a standard E cell, difference of two. Right? This difference of two electrode, a standard electrode of copper minus a standard electrode of Zn. For that only one term you are writing, E standard. E standard for cell. Cell made up of copper and Zn, or Zn and copper, no problem. Then now this for log term you have to think over. Only here a student gets confused and do mistake. Here you should be only in this step, you should be careful. Then what should be careful? First 0.059 divided by n, it is common. Then keep it outside, out of a bracket. Correct? Step by step you will go, then you will not face any problem. Means you can consider it as a one step. Then sixth step you can write this thing. All things will be carried on, means E cell is equal to standard E cell plus outside you have written 0.509 divided by n outside. The inside bracket, what is remaining? The inside bracket, what is Zn 1 log base 10 1 upon Zn plus is remaining, minus log base 10 1 upon copper Cu plus term. These two terms are remaining. All are associated, both are associated with log base 10 1 upon Zn plus plus, molar concentration of zinc ion, minus log base 10 1 upon molar concentration of copper ion. In bracket you have written these things. Then now here what you have to do, actually this question is asked, that's why I am telling you in 12th exam they will ask to derive, okay, and in competitive examination their relation will be important and this concept will be useful. Then now see what you have to do next step, because both are log term. Then here easy things I am telling you. This step is the only complicated step. Sixth step is complicated step. But here you will not face any problem, because you are understanding what you have to apply here. Then this, you know, mathematics I am telling you, you are applying mathematics, not the chemistry. Then here what you are applying here, then you know one mathematics log formula, you know that log x upon y is equal to log x minus log y. This formula you are knowing. Log x upon y, that is equal to log x minus log y. This formula you are knowing. This formula you are going to use here. Then here log x minus log y value is given, means log here log 1 upon Zn plus plus, this 1 upon Zn plus plus you consider as a x, and that side minus log 1 upon copper ion, that you consider as a y, 1 upon copper ion, that you consider as a y. Then it became log x minus log y. Then log x minus log y is equal to what? Log x upon y. That's why in next step, or you can tell last step, what you will do, Ecell is equal to a standard Ecell plus 0.059 divided by n. It is out of bracket. Then now you put the value. Now log x minus log y is there. Then now it will become log x upon y. Log x upon y. Now you put the value of x and y. Hence 1 upon Zn plus plus divided by 1 upon copper plus plus. Correct? This is the only step. Now you put the value of x and y, means 1 upon Zn plus plus divided by 1 upon Cu plus plus. In one step you can go more, no problem. But if we will try to just escape, then chances are there for error. Hence in derivation, you try to go, if complication is there, some complication is there, then you go better one step, no problem. Then now you are knowing, then this is actually final step, but now you have to simplify it. The next step, eighth step, you can, again all things will be carried on. Ecell is equal to E standard cell plus n 0.509 divided by n. Now what you write? Log base 10 you have written. And now 1 upon Zn plus plus. Now it will be reversed. Now down portion, denominator will be reversed. Copper will go upside, one will come down. Correct? Then finally you will get what? That is the 1 into copper, that is the copper only, a Zn into 1 again, Zn only. Hence you will get in bracket what you have written, outside 0.059 divided by n, but now you can remove the bracket because you have solved. Then log base 10, now you got what? Copper is upside, Cu plus plus divided by Zn is down. Zn plus plus means concentration of copper ion, concentration of Zn ion. Okay, this you got it. But here one thing is just to think that a step when this second step only you think when you have put the value, ER and EL, that's a step you should be careful for sign, because ER minus EL, then ER expression you have written, EL expression you have written. In the middle sign, this thing minus sign was there. Then now considering this, all things you have done correct. What you have done, that you have done correct, all the step, final step you got. But what I want to tell you now, that you can make one more change. Okay, you can make one more change. What change you want, you can make it. The now final step you got, copper ion is upside, Zn ion is down. Okay, numerator copper is there, Cu plus plus, and down denominator, that is Zn plus plus is there. Correct? And before 0.509 divided by n, positive sign is there. Correct? If you want, you can make the change. How? Then just reverse it. If you want to bring it, you can say this Zn upside. Suppose you want to reverse it, means Zn upside and copper down, then this sign will change. Before 0.509 divided by n, now it is a plus sign, that will become minus sign. Okay, if you want, you can do. Generally result will be in minus term, but you should write plus only if you are confident in this way only. But I told you, when you will make a change, means denominator if you want to bring upside and numerator down, then sign will change. Only this you keep in mind. Okay, then this you have derived. This is a final derivation you have done for Ecell. Okay, in many books some error is there, but now what I told you, I have corrected all the things. Now it will not face any problem. Okay, that's why when you are second step should be careful. After the second step, because after writing the expression, minus becomes plus, that you have to keep in mind. And this plus term first you write, then minus term you write. Correct? This is the only here to this think. You have to remember. Don't do here. First you write Zn, then you will not do any mistake. After that, minus 1 upon copper, whatever. These things are only important. After that, only easy things are there. Simplification is there. Main thing is there only. First 1 upon Zn you write, and then you write minus 1 upon copper ion. That is the only here you have to take care. Okay, and like that way, I am telling you, if any other cell is there, then same way for that cell you can derive the Ecell. Same way, you know that different type of cells are possible. As for example, now I am telling you, suppose nickel and silver, nickel electrode and silver electrode, both are joined. Then it became the cell. It became the cell, means nickel. Nickel means, you know that first you have to write oxidation and then you have to write reduction. Don't forget, expression you have to write in this way only, cell expression. First anode, after that two vertical line, and then cathode. Yes, first anode, then cathode. The anode you will write oxidation reaction. Oxidation reaction means Ni is becoming Ni++. Okay, then this is the anode. Cathode, silver is there, silver. Then here Ag plus will become Ag, silver. Silver ion will become metal, silver metal. Then one side anode, other side cathode. Only when you are deriving, then you write expression for both electrode only in term of reduction. Reduction, single electrode potential for both will be the same. This is the very, very important point. Reduction potential for both electrode will be the same. You have seen, same type of expression was there, only Z and copper differed. Like that way, here again this will differ only in nickel and silver. That's enough. One more thing here you have to, in this expression, you should be careful, because here nickel is converting into Ni2+, 2+, correct? 2 electron it is losing. But silver is gaining 1 electron, Ag plus, 1 plus, and Ag. Only 1 electron. Nickel is losing 2 electron, but silver is taking only 1 electron. Then what about the second electron? Then there, before the Ag in a balanced equation, you will write 2 Ag, because electron should be balanced. You have to balance the electron. Then when 2 electron is coming, then two silver ions should be there. Then it will be balanced. Hence, before the Ag, 2 you have to write. Okay, 2 Ag plus you have to write. Understood? Then this is the only things. Then for this cell, final expression will be there. You have to not derive. When you have derived, same way you will derive. But I am telling, for this type of cell, what will be the expression? Then its expression will be Ecell. Ecell will be a standard Ecell minus RT. RT divided by 2F. RT means now if you want, you can write directly 0.509 divided by N, or in general way you can write, you don't want to put the value, then RT you can write RT divided by NF, but in this case N is 2. Here N is 2, and 2F also you can write. And then log you have to not write, ln you have to write, because you are not converting ln into log. You are writing RTNF. Then ln you write ln. If you want to write the log term, then directly 0.509 divided by 2, because n is equal to 2, and that will come log base 10. Any way you can do. I am telling you, you should not get confused by this way. You can write in term of ln also, then don't multiply by 2.303. Only RT divided by NF you can write, then ln you can write. But better for solving the numericals, what I told you, 0.059. Okay, that you write 0.509. That term you use, then it will save your time. Okay, that term is very, very important. You can solve it. Now this you can for this cell, for nickel silver, electrode cell, here this you will write final expression like E cell is equal to E standard cell minus RT divided by 2F, because N is equal to 2. Ln nickel concentration Ni 2 plus in big bracket to write, that is called molar concentration. Always concentration term you write in big bracket. And down what you will write? Then here you will write silver ion in bracket you write big bracket, but power will be 2, because in balanced equation 2 Ag you are writing 2 Ag. Then what is the power, what is the this coefficient that will go as a power? That things that you also know, and in chemical equilibrium chapter you have seen. Then here only difference is that Ag plus sign you are writing in big bracket and power will be 2. This is the extra things. Then this is the actually expression for this cell, nickel silver cell, nickel cell. Okay, nickel silver electrode cell. Then now in a general way, if you want to represent any cell, if you want to represent E cell in a general way, then how will you represent? Then first you have to write the reaction, balanced reaction you have to write. Then suppose you have written equations, you have written this as for example A plus B, that is equal to C plus D. Okay, means A plus B is giving arrow sign you can write, or equal sign. Better you write arrow sign. A plus B arrow sign is giving C plus D. C and D is the product, A and B is the reactant. Then you don't know what is its coefficient, what is the coefficient of A, what is the coefficient of B, what is the coefficient of C, what is the coefficient of D, you don't know. That's why for capital A you have written A plus B, both are capital, A plus B, and C and D also is the capital. But now you don't know coefficient, then for the A, how many A are there? You don't know. A small a you can write. A small a is the coefficient. A small a and capital A, plus B, a small b and capital B. Arrow sign C, a small c and capital C, plus D, a small d and capital D. Then now here in general you have to write the E cell. Then now a general equation is ready. Then E cell is equal to standard E cell. E cell is equal to standard E cell minus RT NF, minus RT NF ln. Now you write Q, and for the Q what you will write? First you should write the formula. E cell is equal to standard E cell minus RT NF ln Q. Now in the place of Q you write this expression K, that is a dissociation, that K value, that is the C into C divided by A into A, molar concentration of products divided by molar concentration of reactant in the place of Q. Then what you will write here? C power C. In the place of Q, you are writing C power C into D, capital D power small d, capital C power small c, into capital D power small d divided by capital A power small a into capital B power B. Means A, B, C, D, all you have to write in bracket, and upside you write values, coefficient values upside. Means C power C, D power D, and down A power A, B power B. Then this is the general expression for E cell. general expression for Ecell. In examination, they will give two electrode potential they will give. Standard potential they will give. As for example, for copper they will give, for Zn they will give. Both standard value they have given. Now what will be the, you can say, standard Ecell? Then now deduct both. Both you have to deduct. Means copper and Zn, what is the difference? You have to deduct. Means right, always think right minus left. When you are standard Ecell, you are calculating the right minus left. Then right is copper. Then from the copper you deduct Zn value. Copper value minus Zn value, not the reverse. It will be wrong. Always remember R minus L, ER minus EL. You will not do any mistake. Everything will be right. Then if copper and Zn both values are given standard values, you want Ecell, standard Ecell, then from the copper you deduct Zn. Because in Daniell cell, this is the arrangement. Correct? Zn is left side, copper is right side. That's why copper minus Zn. Then Ecell value like that way will get. Or any other cell is there, suppose any other cell is there, then by seeing the value of electrodes, you can write the cell expression. First you have to write the cell expression by seeing their values. Because the negative value, more negative value will be anode and less negative, if both are in negative, then more negative will be anode, less negative will be cathode. If they have given a negative and positive, then no problem. Minus will be anode, plus will be cathode. If both are in positive, then less positive will be anode, more positive will be cathode. Then like that way you can write the Ecell. Anode and cathode quickly you will remember. Quickly now you are knowing which is the anode, which is the cathode. Then electrode expression you can write. You can represent the electrode. First you write anode, double line, and then cathode. Then for these two steps also marks is given. For the anode, marks will be given if you are writing correct anode, correct cathode. If you are making the cell, representing the cell, for that also marks will be there. And after that you will apply the formula. Correct? Then no problem, quickly you can do all the things. Then these three steps are very, very important in solving the numericals. Correct? Expression quickly you will calculate by seeing the reaction, balance reaction. If it is a coefficient is no coefficient is there, then no problem. If any coefficient value is there, in case of here nickel and silver, then 2 Ag. Then simply all things do, only in the final stage this coefficient will go to the power. That is the only difference. And always you keep in mind, for metal concentration is unity 1. For gas also 1. Any gas, S2, N2, O2, any gas. This for the solving the numericals, it should be careful. Then this I have told you about these things. Ecell, how will calculate the Ecell. Okay, one numericals is there already. I have discussed same type of, only value you have to put and you will get the result. What is actually this question? Then here this one general type of question is there. Magnesium plus, actually question I am reading first. Represent the cell in which the following reaction takes place. What is that reaction? Then Mg, means Mg will be solid. Mg plus 2Ag, and A2Ag plus, its concentration is given in bracket its concentration is given 0.00030, 0.0001, 0.000301 m. This is the, because silver ion will not dissolve too much, that's why value will be less only, 0.0001 m. And product they have given magnesium Mg2 plus, Mg2 plus, and its concentration is given 0.130 m, means molar solution, capital M. Then for silver ion also molarity is given, concentration, magnesium ion also concentration is given, and other product is 2Ag solid, means this is the reaction, Mg solid plus 2Ag, and concentration value it is giving Mg2 plus 2Ag solid, means in any reaction you know that Zn is converted into Zn ion and copper ion will convert to the copper metal. Same things are here, equation they have given. Then you have to represent the cell, you have to make the cell, okay, and also you have to calculate the Ecell, calculate. If a standard Ecell is equal to 3.17 volt, correct? Two things you have to do. First, you represent the cell. Second, calculate the Ecell. Then now both you can do very easily. See the value and then you can take the decision. Okay. Here you have to write the, first you have to write the these things. You have to represent the cell. Then for the cell you have to write the cell, you have to first you have to find out these things, anode and cathode. Then here actually I have sent one distinct chart, that is for electrode potential. Okay, for a standard electrochemical potential table I have sent already. In that so many electrodes potential is given, because sometimes you have to remember value. Okay. Then electrochemical series, that table electrochemical series I have sent. Then for some common electrodes you have to remember the value. Here magnesium and silver is there, magnesium and silver. Then magnesium actually is a negative and silver is a positive value. If you see that data, then you will find that silver, first thing magnesium is you can say negative value and silver is positive value. Then obviously magnesium will be anode and silver will be cathode. And now easily you can write Mg2 plus oblique Mg, anode you have written, 2 line you write, vertical line, that is for salt bridge or separation. And after that you write, what you will write? Silver, Ag plus, and after that Ag plus is converting into metal, then Ag plus oblique Ag, and only there you have to write in bracket for magnesium ion what is the concentration, only in bracket you have to write. Then magnesium ion concentration value you write, okay, and silver ion concentration value also you have to write. Then now first part is over. Magnesium ion concentration value is, you know, it is given 0.130 m, and silver ion concentration value is 0.0001 m. Then now first part is over, you have represented the cell. many times they will give the value of these things, potential, value of oxidation potential, reduction potential, or reduction potential. They will give the value, all will valuable in the term of reduction potential only, just to see the value, negative, positive, and take decision. And now after that, Ecell you have to write. Then Ecell is very easy to calculate. Ecell is equal to a standard Ecell minus RT divided by 2F ln Mg2 plus divided by Ag. Divided by Ag. Here actually one thing I want to tell you, this always you first write upside reduced state and then down oxidized state. Then reduced state means after taking the electron, it is converting to metal, means Cu plus 2E. Now it converted to Cu, copper metal. Then this is a reduced state, means Cu plus oblique Cu, that is the reduced state, and oxidized state means Zn, it is converted to Zn plus 2E, that is the oxidized state. Means metallic form will be reduced state, ionic form will be oxidized state. This also you should write. Okay, then you are writing product by reactant, that time this whole concept you can write for electrode potential, for electrode this thing, single electrode potential. Then here all data value is given, RT upon 2F ln Mg2 power it will go divided by Ag, because Ag power 2, because 2 Ag is there and Ag power 2, and here you are writing minus RT NF, because you have reversed it. What was the original term, that was the in plus, now you have reversed, that's why it is telling minus. Okay, then it is a magnesium divided by concentration of silver ion square. Then Mg value you write, and silver concentration value write, and you quickly will get the result. Okay, means RT and because ln is there, you can convert into the log by multiplying 2.303. Down is F, but only N is equal to 2 here. Magnesium 2 plus means 2 is there, N value N is equal to 2. Then 0.0591. Okay, that value divided by 2. 0.0591, not 0.50, 0.059, it is less value, 0.0591 or 0.059 also you can write. Then it will come that value 0.0591 divided by 2, and log you have put the both concentration, magnesium concentration 0.130 and silver concentration is 0.0001 power 2. After solving, result will come 2.96 volt. Okay, actually Ecell value is already given 3.17, standard Ecell, and after solving this second term means 0.059 and divided by 2, and log this 0.130 divided by 0.0001 power 2. After solving this, this value will come 0.21, 0.21. Then this 3.17 minus 0.21 V means volt. You will get finally 2.96 volt. Okay. Then this I have numericals I have explained you. Now how to solve. Next class I will continue conduction. Okay. Equilibrium Equilibrium constant I will discuss equilibrium constant. Then I will come for the conduction. Thank you.